All right, polar coordinates. These videos are for anyone that missed class, but also for the classes because we've been running low on time and not being very productive. So the first thing about polar coordinates is that you're going to be on a graph that looks like this. Where the rings are the radius, and then the location is still for theta is still the same as the unit circle. So on the unit circle, the thing about the radius was that it was always 1. That's why we only had one deal on the unit circle. So it was always 1, and then we just found where we went. So like this was 0 pi, this was pi over 2, this was pi, this was 3 pi over 2, and then this was 2 pi also. And it keeps going. So like you can add or subtract 2 pi for any rotation. So if I got something that told me to go to pi over 3, I just went to pi over 3, which was right here, and I made that point. So what we're going to be doing essentially is the same thing. We're making the location, but we're also going to have a radius. So instead of being in the form of xy, we're going to be in the form of radius and theta. So it's going to give me something like 4 comma pi over 4. So if I'm going to 4 comma pi over 4, I'm going to go to the fourth ring and then pi over 4, which is right here. That's how I would graph that. If it told me 2 comma pi over 3, I would go to the second ring and to where pi over 3 is, which is like right here. Oops, not on the first ring, on the second ring. My apologies. And I would graph that point. Fairly simple. However, if we have a negative radius, meaning that I have something like negative 2 pi over 3, I need to reflect it across the pole. And this point in the middle where we used to call the origin is now called the pole in polar coordinates. So this point right here, instead of being called the origin, it's called the pole. So if I reflect across that, if I have something like this, I go to the second ring, I go to pi over 3, which is right here, and then I reflect it across. So that's going to bring me right here. Now that's how everyone does it. Literally everyone does it. For me, it seems easier to just say what I would normally have right here. I add a pi, so that would give me 4 pi over 3. So to graph that, I would go to 2 comma 4 pi over 3 when it gives me a negative radius. So I would go to 2 and then 4 pi over 3, which would be right here. Okay, that's how I do it, but that's not how it's expressed. So I don't want to confuse you by expressing it differently than you're going to see it in the future. If I'm in degrees, if it gives me something like 3 comma 300, I'm going to go to the third ring and I'm going to go to where 300 would be. So this is 180, 270, and then right here would be 300. So we're still doing the same thing. If it gives me a negative radius in there, then instead of adding a pi, I would add 180. 180 is the same thing as a pi. So I'm going to go to the second ring. I'm going to go to 300, which is right here. And I'm going to add 180 degrees, which means I'm really going to go right here. So essentially that's what I'm doing. Now if it gives me a negative angle, that's okay. Instead of rotating counterclockwise, I'm just going to rotate clockwise. So I'm going to go to the second ring, and I'm going to go negative pi over 3, which is right here. Okay? So that's the fairly simple part. Now they'll also ask me sometimes to graph other points, like it tells me this, and it says graph 2 other points. Well, not graph 2 other points, because graphing it would be the same, but represent this as 2 equivalent points. So the way that I do that is I just add or subtract 2 pi. Because remember, every time we do 2 pi, we just make another rotation. And we covered that when we did the unit circle. So this one, plus 2 pi is 8 pi over 4, which is going to be 2 and 9 pi over 4. So that's another representation that would be the same point as that. Subtracting 2 pi minus 8 pi over 4 would be 2 negative 7 pi over 4. So that would be another point that is the same representation as that. And we can do as many rotations like that as we want.